Hello everybody, this video is a quick review of the basic ideas of chapters 5 through 8. We'll talk about calculator commands that you will need to use on your test, and also I will mention some of the most frequent mistakes that I've seen over the years. Okay, what was the first concept that we discussed? First we talked about discrete random variable, right? And this was section 5.1. What kind of problem you can expect to see? So you will have a table with values on the left. So you will have some values here, and then their frequencies on the right. Okay, so this is similar to problem 1 and activity 5. So this is activity 5. Okay, and then what you need to do, you need to construct a probability distribution. Okay, so what you're going to have is a table where you will have x values here and then probability of each of the value. All right, so how do we do this? We take our frequency for each of the probabilities. We take the frequency and divide it by the total. Okay, and that's going to be your probability. Remember, the sum of all probabilities should be equal to 1. That's how we know that this is a probability distribution. So once you do this, what I would do is I would put my x values in L1 and the probability in L2 in your calculator. So if you go to a calculator, go to stat, add it. Okay, and plug in your x values here, your probabilities here, okay, and then you will be able to compute mean and standard deviation. All right, now I can ask you, once you come out with the table, I can ask you a bunch of questions such as, okay, what is the probability that the random variable takes a value at most 3, for example, right? So let me just remind you that at most 3 means 3 or less, right? Okay, what if I ask you at least 5? So at least 5, that's 5 or more. All right, so then depending on the question, if it's 3 or less, you would add all of the probabilities where the value of x is 3 or less. And then the same thing for 5, at least 5. If it's 5 or more, you would add up all the probabilities where the random variable takes a value greater than 5, greater than or equal to. Okay, so you would just use your table right here, this one, to compute your probabilities. Now, to calculate the mean and the standard deviation of your random variable, so mean and the standard deviation of your random variable, the other way around. So that's your mean, that's your standard deviation. Okay, you don't need to do this by hand. What we need to use is our calculator, and the command here will be 1 variable statistics. Okay, and then we do L1 comma L2. That is on TI 83, right? So you would do 1 variable statistics L1, where L1 has x values, L2 is the probability. All right, now if you have 84, I believe this L2 will be just put into the column that says frequency. Okay, so that is your frequency. So the most common mistakes that I've seen over the years is students just using 1 variable statistics L1 and forgetting that you also need to include L2. Okay, so that's your most common mistake. All right, forgetting this part right here. Now it's going to compute the mean of just the values in this column right here, but that's not correct. Okay, because now each of the values has a weight or probability associated with it. So we got to remember to put L2. Okay, so that's all you need to know as far as the basic idea, but a quick review of section 5.1. Okay, let's take a look at the next thing. Then we talked about binomial. All right, so binomial distribution. For binomial, you need to have a finite number of trials. So this is your number of trials in an experiment. Now, let's see, each experiment will also have two outcomes, either success or failure. Okay, and success does not necessarily mean something positive, or failure doesn't necessarily mean something negative. It's success is just what we expect, what we would like to see. Okay, only two outcomes. So only two outcomes, and that's why we have binomial. Bi stands for two. Okay, let's see, we have P, that's the probability of success. Probability of success that doesn't change. So this probability is fixed from trial to trial, and our trials are independent. Okay, so that's how you know that your problem is about binomial. Okay, so once you have that, you can answer a bunch of questions. So for example, let's just, for the sake of argument, let's say that our probability of success is 0.35, and we have 20 trials, and we want to find the following probabilities. If I were to find that the probability of success is exactly 4, what does that mean? So if I do 20 trials with this setup, and I only want to see exactly 4 successes, well, I would do binomial PDF. Okay, and the syntax here goes like this. Okay, first we have number of trials, then the probability of success, and then the number of successes that we want to see. Oop, I know what my x is. Okay, my x is 4. All right, so this command right here will compute the probability of getting exactly 4 successes out of 20, where the probability of an individual success is 0.35. Okay, so that's what we'll do here. Now let's say I say the following. What is the probability that at most I'm going to get 9 successes? Okay, at most that means 9 or less. So in this case, I would use binomial CDF. Okay, binomial CDF. All right, and then the syntax is exactly the same. So 20, 0.35 up to 9. Right? What this command is doing, it's computing the probability of getting exactly 1, 2, 3, or actually 0. So 0, 1, 2, 3, all the way to 9 successes, and then it adds it all up. So that's how you would use this command to say at most. Okay, so to compute the probability of getting at most number of successes. Okay, what if it says at least? Probability, let's say at least, I don't know, let's say 5, at least 5. So this is 5 or greater. Okay, now your calculator cannot compute the probability of getting 5 through 20 successes, okay, in one command. It can't do that. So what you're going to do here, you're going to do 1 minus probability that you're going to get the opposite, which is 4 or less, right? So the complement of getting 5 or more is 4 or less, right? Now, but this one right here, this one we can compute with using a calculator. So this one is 1 minus binomial CDF 20.35 4. Okay, so this one, this command, 1 minus the complement, is when you need to use at least. Okay, so that's what we do here. So binomial probability, first you got to figure it out that these requirements are satisfied, right? And then once that's done, just set up your questions in this manner. So P is equal to X is equal to number. If that's the case, then you will be using PDF. Okay, if it's less than or equal to, then you do CDF. If it's greater than or equal to, then we do 1 minus the opposite, the complement. Okay, so that is your second problem with binomial. Okay, let's take a look at the next topic that we discussed. So now we talk about normal distribution. So this is section 6.1 through 6.2. Normal distribution. Okay, here you will have a population that's normally distributed, and then you would have a mean sitting right in the middle, right? So two commands that we need to know how to use here. First one is normal CDF. And what is the syntax here? We go low limit, high limit, mean, and standard deviation, right? Okay, so low number, high number, so number on the left and number on the right, and then mean and standard deviation. This will let us find the percentages of the proportion that will satisfy certain conditions, okay? That's your first command, and then we also need to know inverse normal. So inverse normal, what does this one do? This one will tell us percentiles, right? So percentiles found with this command right here. So what do we do here? Okay, the first parameter that you're going to put in is area to the left. And then we do mean and standard deviation, right? Okay, so area to the left is the first thing that we got to put in. Then mean and standard deviation. The order of these commands is definitely important. Okay, so this one was activity 6, I think, activity 6. All right, so problem 3 and 4 are most likely the ones that will be similar on the test. Okay, but what I recommend is actually making a picture like this. So let's say your mean is 80 and the standard deviation is 4.5. It will ask you something like this: what is the 35th percentile? Okay, so then you say, all right, 35th percentile somewhere here, right? 35th percentile. So area to the left is 0.35. So then you would put in inverse normal 0.35, 80, 4.5. Right? And then you would find the number, and you got to keep in mind that, okay, it needs to be less than 80, right? Because this one is my 50th percentile. So it better be less than 80. Okay? So what is a common mistake that I see? Okay, the most common mistake that I see actually is not so bad, but when you guys are using to find a large number or a small number, I know the book is telling you, okay, if you want to find a small lower bound or large upper bound, so you would do 1 e to the 99. You can do this. I just want to make sure that you don't make a simple mistake using this e right here. So that's a very large number. Oops. Okay, so you would do 1 e 99, right? A lot of times I see students trying to do this number right here. So this e right here represents something different. This is an exponential. Okay, this is the base of the natural log. So if you were to do this number, you would get an error. You would get different answers. So the easiest thing to do is actually, you don't need to do 1 e to the 99. You can just take a large number. So you can do something like this. That's good enough. Okay, if it's a small or large negative number, then just do negative this. That will also work, okay, if that's easier. But other than that, these problems students usually do pretty well. Okay, so normal distribution, activity 6, I think that was problem 3. Okay, that's something similar to that will be on the test. Okay, then what is the next thing? Let's talk about sampling distribution. Sampling distribution. Okay, this would be section 6.3. Now, as far as the commands go, if you go up here, let's see. For 6.1, 6.2, we use normal distribution, but you would actually be given that the population is normally distributed, and then you can apply these commands. Over here, population is not necessarily normally distributed. So population does not need to be normal. Okay, but we still be using normal distribution because the central limit theorem lets us do so. Okay, so you're still going to have a normal curve because central limit theorem says if your sample is large enough, right? If your sample is large enough, then we can use normal distribution to model sample mean. Okay? Now here you're going to have your mean sitting over here, but now this is a sample mean, right? And the commands are exactly the same as before. You will have normal, CDF, low, high, mean, and now the only difference is going to be sigma divided by square root of n. So that's the most important part of this type of problem. Do not forget that you no longer have a normal distribution. You have distribution of a sampling mean. We can still apply the normal distribution, but we got to take care of this standard deviation. Okay, the inverse normal is still applying. Now we still have area to the left, mean, and our standard deviation is divided by square root of n. Okay, this is the most common mistake that I see happening. Okay, forgetting about this sample size being there. It's there for a reason. So as soon as you see that the question is about sample mean, that's when you know that we gotta use sigma divided by square root of n. Okay, so this was activity 6. The last problem was dealing with that type of concept. Okay, population does not need to be normal. Your sample size is usually going to be pretty large. We still apply normal, CDF, and inverse normal. Okay, again, this one is still to find percentile, right? But this part right here is the most important thing to remember. Okay, so that's chapter 6. Chapter 7. What is in chapter 7? Let's see, this was 4. So chapter 7, we talked about confidence intervals, right? Confidence interval. When you guys are asked to find a confidence interval, the first thing that I would do, actually try to figure it out. What are you dealing with? Are you dealing with population mean or population proportion, right? Proportion. So again, is this quantitative data that I can measure with units, or is it categorical data? Now, once you have population mean, there's 2 options here. Sigma is given. If sigma is not given, then S is given. Okay, so your standard deviation, you're always given some sort of standard deviation. Sigma is standard deviation of population standard deviation. S is standard deviation of a sample. Okay, now if we have sigma, then we use Z interval. If we have S, we use T interval. All right, so this is population standard deviation. This is sample standard deviation. Okay, and usually it's pretty clear which one is which if you read the problem very carefully. Okay, if you're given population proportion, then there's only one command here. It's 1 proportion Z interval. Okay, so that's what you would use here. Again, what do you need to know? You need to know X, which is the number of people that fall into a specific category, depending on what your categories are, right? And then N is the sample size. Okay, and then, of course, you need to know confidence level. All right, and then you would have a conclusion that will say something of this sort. We are 95% confident that the given interval, the one that we've computed, actually contains the population mean or the population proportion, depending on which one you're dealing with. Actually contains the population proportion, let's say, and then you finish it with the context of the problem. Okay, now what if you're asked to find a sample size? If you're asked to find a sample size for a mean, then we would use the formula that looks like this. N is equal to Z of alpha over 2 times sigma divided by M, where M is the margin of error, all squared. And then if it's population proportion, and then we'll do P times 1 minus P Z alpha over 2 divided by M quantity squared. Okay, so the common mistake that I see more often is people confusing these two formulas. So let's say you have a problem about population mean. If you're going to try to do this formula right here, it's not going to work. It's actually going to give you either negative numbers or numbers that don't make any sense. Okay, so again, try to figure it out. Which one are you dealing with, population mean or proportion? If it's mean, that's the formula that you're using. If it's proportion, this is the formula that you're using. Now, if P is not given to us, then assume P is 0.5 if it's not given. Okay, and the other thing that we need to remember is that we need to always round up. And the same here, we round up. All right, so this is your confidence interval setup. Again, first thing, figure it out if it's mean or proportion. Then if it's proportion, you're good to go. You just need to use this command here, come up with the conclusion at the end. If it's mean, figure it out, is sigma given or S? If it's sigma, it's Z interval. If it's S, then it's T interval. Okay? Let's see, what is the last thing that we've discussed? The last thing was hypothesis testing. Okay, so what is this? Problem, so 6, hypothesis testing. This is chapter 8. Yep, chapter 8. Okay. Okay, again, just like with population, proportion, and mean for confidence interval, the first thing that you guys want to figure it out is the following. Is my hypothesis testing about a mean or proportion? If it's about mean, then set up your null hypothesis. It will say something, mu is equal a number, okay, and the alternative would be mu is either not equal that number, might be greater than or equal to, or less than or equal to. Okay, a common mistake that I see is that this number must be the same. Okay, this has to be the same number, and it's not the test statistics that we've collected from a sample, right? It's something that is accepted to be true. All right, so some previously known information. Similarly for proportion. Okay, the H naught would say that the proportion is equal to some number, so let's say 0.30. And remember, this has to be in decimal. Okay, and the alternative will either say that it's not equal to 0.30 or maybe greater than or less than. Okay, but again, this number needs to be the same. Just like with mean, it has to be the same number. Okay, then let's see, if you're dealing with the mean, sigma given, z-test, S is given, t-test. Over here, it doesn't matter, you just use one proportion z-test, right? Okay, so depending on your standard deviation for the mean problem, if it's population standard deviation, we do z-test. If you're given sample standard deviation, we're using t-test. And then what happens? You compute your p-value. A common mistake here is computing p-value and excuse me, not interpreting it correctly. So p-value cannot be greater than 1. Cannot be greater than 1. Okay, I do want to emphasize this. So no value greater than 1. It needs to be between 0 and 1. It's a decimal, right? And what's the conclusion here? So we take our p-value and what do we do with it? We compare it to alpha level, right? So you take your p-value. If it's less than alpha, then we reject the null hypothesis. We say that there is sufficient evidence to conclude that alternative hypothesis is true. If p-value is larger than alpha, we fail to reject. Fail to reject H naught. Okay, we say there is insufficient evidence to conclude the alternative, right? So we cannot reject the null. Okay, so always compare your p-value to alpha. Now, what is the situation where p-value can be greater than 1? Well, let's say you get something on your calculator, you get something that looks like this: 1.39 e onto the negative 10. Okay, something like this. This is actually a very small number. Very small number. Okay, this negative 10, that means that there's 10 zeros over here. Well, actually 9 zeros and then 1. So this is using scientific notation. So that's a very small number. So your p-value is definitely not greater than 1. So make sure that you interpret it correctly. Okay, so this is very small. In this case, you would reject the null hypothesis. Okay, so that's what you would do for hypothesis testing. And then the only other thing that I would like to discuss is types of errors. So type 1 error. When does this happen? When H naught was true, but we rejected it, right? So you would say, in reality, H naught was true, but we rejected it. Okay, so put it in the context of the problem. This is equivalent to sending an innocent person to prison. Okay, type 2 error. Okay, when H naught in reality was false, but we failed to reject it. Okay, again, put it in the context of the problem. Here you would say that, okay, whatever the alternative we got, well, the null hypothesis was false, but our alternative wasn't strong enough, right? So our evidence was not strong enough to reject it. Okay, so that's type 2 error. And my last video was about writing these in the context of the problem when you're given, right, a problem. And then your last problem on activity 8 is also dealing with that type of problem. Okay, so that's actually everything that I would like for you guys to review before you go ahead and take the test. Okay, all right. Good luck, everybody. If you guys have any questions, don't hesitate to email me. I will be looking through my email a lot, so just go ahead and send me a quick email, and I'll be able to answer any of the questions. Okay, thank you for watching.